Hi guys, welcome to the last section, Taming Time Series Data Using Deep Neural Networks. In this section, we will look at topics such as time series data and traditional approaches to solve them, overview of deep neural networks, MXNetR package, go over time series use cases and data, deep learning solution for our time series problem. Now, we move on to the first video of this section that deals with time series data. In this video, we're going to take a look at time series data, seasonal and non-seasonal time series, and time series as a regression problem. Time series data is not a new type of data. Algorithmic trading is the use of computer programs to generate and follow a defined set of instructions to trade in the market. This allows profit to be generated at a greater speed and frequency compared to a human trader. Algorithmic trading leverages time series data. The traditional approach to time series data involves analyzing it in frequency domains or temporal domains. Time series data is not just limited to sensor data and financial data. Let us quickly look at some examples of time series data. We will use some data from Rob J. Hindman from this website. We will use the age of death of successive kings of England dataset. Let us store the time series data as a TS object using this highlighted lines of code. Using the scan function, we will get the data from the URL. Following that, we create a time series object using TS function. Now, we will plot the time series. The standard rplot function knows how to plot time series data. Here is the plot for time series. Time series can be either non-seasonal or seasonal. Non-seasonal time series tend to have a trend component and an error component. We say a trend exists in the time series when there's a long-term increase or decrease in the data. It does not have to be linear. An additive model is used to estimate the trend of a non-seasonal time series. The time series can be smoothed to remove the trend using methods such as moving averages. The trend can be either increasing or decreasing. Let us perform smoothing using a simple moving average. The TTR library provides the SMA function to perform the smoothing of the data. The n parameter defines the order of the moving average, which means how many points we want to consider to do our moving average. Now we will look at the plots of the smoothed time series. Here is the plot for n equals to 2, n equals to 5, n equals to 10, and n equals to 15. Seasonal time series have a trend, error, and a seasonality component. We will use another small data set to show seasonality, the number of births per month in New York City, from January 1946 to December 1959, using this set of lines. Using the decompose function, we split the trend, seasonality, and error from the time series. Let us now plot these components using plot function. We see the individual components, trends, seasonality, and errors in the graph. The time series has to be made stationary before we use any regression methods. Let us do a simple regression exercise with our time series data. We're going to predict the age of death of a king based on the age of death of the previous king. It's a simple example, and hence may sound very strange. The idea is to show how regression is used to do time series forecasting. First, we will smooth the data to make it stationary. We use the SMA function to perform the smoothing. Let us now create our x values. We are using the quant_mod package to get the lag of the time series. Our predictor is the age of death of the previous king. Hence, we take a lag of 1. Finally, our data frame, new.data, holds our x and y. Next, we will build our linear regression model. By using the LM function, we have built our linear regression model. Finally, we will plot our model. Several plots are generated. Let us look at the residual plot first. The residuals follow a straight line. This plot shows whether or not the residuals have non-linear patterns. We can see equally spread residuals around the red horizontal line without distinct patterns, which is a good indication that we don't have non-linear relationships. Let us look at the QQ plot. This plot shows whether or not the residuals are normally distributed. This plot shows the standardized residual plot. Next is the residual versus leverage plot. Hopefully, it gave you an idea about how to rearrange time series data to suit a regression problem.